Hello everyone, and welcome back to Copper State Cresteds. Today we're going to be talking about Lilly White Genetics. Okay, so first off, I want to let everybody know that I'm so thankful for all of my subscribers as well as 1,500 followers on Instagram. So I have made the decision to do a Crested Gecko giveaway. As I wanted to celebrate 1,500 followers, as well as the fact that I do have a lot of hatchlings and juveniles that are ready to go to new homes. And so I decided I would do a giveaway because I know it's not in everybody's finances that they can afford a gecko or a new pet or even a really great grow out, because these do have really great potential. All of my geckos, I feel like, are high quality and usually breeder quality. So that's up to obviously whoever gets it. But go to my Instagram in order to enter. You can share the post for an entry, you can tag 3 friends for an entry, or you can subscribe to this channel. The thing about subscribing though is you have to have your subscriptions on public so that I can see that you subscribed. And then, then we will be doing this giveaway when I reach 500 subscribers on this channel. Again, because we keep getting interrupted by this crazy. This is a Lenium, by the way, one of my female Lilly Whites that will be breeding this next season to Maxwell. So when we get to 500 subscribers, I will be doing the giveaway. The only terms is that you promise to give it a good home and take care of it with good care methods, and 2, that you will pay shipping. That is the only thing that I'm asking, is that whoever gets it can pay shipping. So, on to Lilly White Genetics. This is Ravenette, everyone. She's not a Lilly White, but she's pretty agreeable to deal with. So, first I wanted to give a little history about the Lilly White. Lilly Whites got their name from the breeder who happened upon the gene, and I don't say discover just because it was a bit of a genetic mutation or an anomaly that never recreated itself other than that first Lilly White that came from 2 normals. I mean never recreated as in 2 normals have not thrown a random Lilly White since. So they originated from Lilly Exotics, who is in the UK. The first Lilly White hatched in late 2010 at Lilly Exotics, hence Lilly White. Once that gecko reached maturity, it happened to be a male, so they were pretty lucky on that fact. And they bred it to 3 females to see if they could reproduce this gene that they saw in it. After they bred it to these 3 females, it started to actually reproduce. I believe they said that the first hatched out of Lilly, they had 2, 3, and 4 hatch out normals, and the 5th or something like those numbers hatched out as a Lilly. And then as they continued their season, they started noticing that these Lillies were hatching at about a 50% rate. So half the time they were hatching out Lilly Whites. So they knew it was a gene that they could recreate. Now, I want to give credit to Lilly Exotics because most of this information is coming from their blog that they posted. If you have not read this blog, which was updated the last time in 2016, so it's been out there for a long time, go and read it. It's really informational. It tells you the whole story, and it's where I got, obviously, a lot of this info up front. The second one that I want to mention is Extreme Cresties. He's also in the UK and got a hold of the first Lilly Whites that were released from Lilly Exotics and began doing his own research with them. Okay, so this is kind of where the genetics lesson is going to begin. So once they figured out that it was recreatable and that it was passing to about 50% of the babies, which makes sense, you'll figure out later, because one parent holds this gene that has the Lilly gene attached to it. So they're passing it on to about 50% of their babies. And then once those babies have grown up, they pair back to Lilly Whites. From there, they paired Lilly to a Lilly to find out this super form. Oftentimes this is shown in a leucistic. So they start hatching out these double Lilly parent hatchlings, and they find out that there is a super form. So that means that that hatchling or offspring got both Lilly genes from its parents. And what they found out is it's lethal. it cannot survive, or there has not been a viable superform of a double Lilly or leucistic type of Lilly White. Now, that is where I'm going to try to explain genetics to you. So I want to tell you, I am not a scientist, I am not a geneticist, I just have done a lot of research, and if you find something incorrect, like, that's totally fine. I'm doing this to inform like the general public about this gene, people that are deciding, I want to get a Lilly White, I want to understand it, maybe down the road I want to breed it, or you're a breeder that just hasn't figured it out yet, or hasn't gone and dug through the interwebs and found these research that it was already done. The other reason that I want to mention this is I have seen some people posting on Facebook groups or online like, oh my goodness, I tried, like I was the first one to ever think of it, pairing 2 Lilly Whites, and I got this super form. How cool is this? Oh, it died. And then other people are coming about like, you're not the first one to think of that. Like, do you really think that nobody else has done it? Go and do your research, because then you'd find out that you're just killing 25% of your offspring. And here is how I'm going to explain. I have it written down on my phone, so I'm sorry if I'm looking down a bit this time, just because it is kind of scientific and I want to get it slightly right, hopefully right, kind of right for you guys. Okay, so if you want to know where you can research this, it's called Mendelian genetics. And I remember this again from 7th grade, it was the P experiment. So it was like tall stalk, short stalk. This guy named Mendel went back and tried this out and discovered that like genes exist and alleles exist. So genes are made up of 2 alleles. Each parent gives their offspring 1 allele. So you get 2, a total, a pair from your parents. When these alleles are the same or identical or matching, meaning each of your parents gave you a matching allele. So with people it would be like each of your parents gave you brown eyes. That's when it's called homozygous. So same type of allele. When these alleles are not the same, it's called heterozygous. So I'm hoping this isn't new to everybody, or it's like refreshing your childhood science classes. So the next thing, we've got that packed away. Okay, homozygous, heterozygous, alleles, we get 1 from each parent. That's like the basics. You also have dominant and recessive, which we know oftentimes with our own selves, it's the easiest thing of blue and brown eyes. So when a dominant trait is present, it will be the one that is visual, because it always outshadows the recessive. Then essentially, in human genetics, like I said, brown eyes, blue eyes. Blue eyes are recessive. I have blue eyes. So I got a blue eye recessive allele from each of my parents. And that meant I had a homozygous, the same, recessive pair of eye color alleles. Now, I won't get into the whole discovery of other genes that play, like hazel eyes and that, but for this talk, we're talking about just simple, you get 1 period and there's only 2 as the option, a dominant and a recessive. So this leads into the understanding, just the basic side of the Lilly White. So the fact that the Lilly White gene shows when 1 parent passes it on, so you've got 2 genes, 1 parent is passing it on, which means it's hiding the other gene, which I'm going to call this the normal gene. So every other gecko out there has this normal gene, and the parent passes on the Lilly White gene and it's showing. That means it's dominant. So we know now the Lilly White trait is a dominant trait. So then we know when you get dominant trait, and now we have another dominant trait of the Lilly White, and they're combining, they both can't show, and it ends up being fatal. Now, that's not the same as other dominant terms. It's like, it's kind of that outlier because it was almost a mutated trait. And I'm gonna get into that kind of in like, I'm on a tangent now. So I actually have drawn up a board for you guys to see this in action. Oh yeah. Okay, so my nerdy self drew this up. So as I've just explained, the big L is the Lilly White gene. Little l is normal. So we've got a Lilly parent here, a normal parent here. And they have two little L's. This one has a big L and a little L. You can see now that when it passes on its big L, you're gonna get 50% of your kids or offspring with that Lilly trait, whereas the other 50% get just normal. So as you can see, we have two L's, which are homozygous of normal. We have a big L, a little L, heterozygous, which is what I was saying with that dominant one showing for Lilly White, and you get 50% or 50% normal. So it's a split. So I wanted to kind of draw this up only because it can get a little confusing when we're talking about that combination of the Lilly to Lilly. So we see here we have, I totally messed up this, so just ignore that fact. But we've got a big L, little L, big L, little L. When you pass down and you do the little like box over, I think you learned this in 7th grade or should have, I'm sorry if you didn't. And we get a Lilly White here. We get a Lilly White here as well, because we have a little L, big L, Lilly White. We also can get normal still, but then we get this dominant double super form of the Lilly that we have discovered is non-viable. So this will always pass away. They've had some that have hatched out and survived a couple of days, passed away. Some that usually fail in the incubation phase. So I just wanted to do this because I wanted to show you the percentage. That even if you wanted to be like, I want to be the person that somehow creates the super form, even though it's been tried, that survives, it just doesn't make sense. Because I've also heard people say, oh, but what if this Lilly, just these Lillies, are like even better, even more coverage? It's not. It's still only one Lilly gene. You know, it's not going to get some crazy nice coverage of Lilly, because it's still the same as if you did it up here. So you're getting 25% normal, 50% Lilly, and 25% lethal. So you have 25% are dying. So yours 50% is the exact same as up here. So why risk it? So I wanted to explain why we do see viable leucistic animals is that there's two recessives. So that little L, I guess, and another little L that hold these leucistic in other species combined, and there is a viable, healthy creature created that is leucistic because there's nothing to block away that white gene, and they were both recessive. So in the form of the Lilly White, it's because they're co-dominant traits. So they're both a big L dominant, and when they try to combine, they fight each other. This is also seen in horses. I believe it's an overo combination creates a lethal form of another leucistic type animal. And then also in Australian Shepherds, that's the blue merle gene that creates type of lethal or deaf, eyesight issues, health issues. So it happens in other ways, but it's almost like two mutated dominant traits that can't combine. This isn't every time, that this happens that two dominants can't show, because obviously we get two dominant traits all the time, like two brown-eye genes, and they're totally fine together. It's just almost like they call it a mutated genetics. So they call this actually formally lethal white syndrome. So that's what I like to almost compare this to, so that people can understand, if they know other species, that this lethal white does happen, and it's because there's two dominants that cannot be dominant together in combination. So the last question that I see a lot that I've gotten questions from customers, and I've seen it in forums, and I'm constantly kind of surprised by it, but it's just because I don't think people really truly understand and grasp how the Lilly White gene works. The question is, hey, I have a normal gecko, one of its parents was a Lilly, will it give me Lilly babies? Can it have Lilly? Is it more valuable because of the fact that it had one parent that was a Lilly and it could potentially have a Lilly baby? No. As I showed you in my chart, a normal that comes out of two Lilly, a pair of Lilly and normal, does not even have a trace of the Lilly gene in it. It has two little L's in that position. So there is nothing that can give it a Lilly gene to pass on. Because when they pass on the genes, these alleles split and it gives one of them. And it's totally random. But if it doesn't have a Lilly gene to give, it can never give it. It's not that hidden recessive trait that we think of with other genes that can be passed on and then shown in one of its offsprings. So no, your normal is just a normal. It is valued as a normal, and it has no chance of producing another Lilly White. I hope that this video has been educational. Again, as the final wrap, a Lilly White has the Lilly White gene. It can pass it on as big L, little l. It can give one about 50% of the time to give you another Lilly White. The combination of two big L's from parents can give you a 25% chance of normals, a 50% chance of Lilly Whites, and a 25% of a fatal form. So again, I really am urging people not to try to breed two Lilly Whites together. I just hate the idea that you're dooming 1/4 of your clutches to death, and it's just not worth it. So please enjoy having the Lilly White, enjoy breeding them responsibly. I really hope to see some full coverage. I hope to be producing some tricolor with high coverage. And also please enter my giveaway. Subscribe to enter, make sure that you are public so I can see that you've subscribed. Go over to my Facebook, Copper State Cresteds, or my Instagram, Copper State Cresteds. Give a follow. Like, it means so much to me. I really am trying to bring out good information, honest information, approachable information. You can comment on my videos, just keep it positive. Everybody needs some positivity in the world right now. I also have a lot of babies up for grabs, so if you are looking for something, let me know. I don't have a whole lot of sexed females because that is what it seems everybody wants right now. I have a lot of unsexed. In spring, if these stay and grow out, I'll probably be able to actually tell you pores, no pores, one way or the other, but they might be gone by then. So if you are looking to add a Crested Gecko to your household and your life or your breeding program, I would love to help you. So that is it for this video. If you have any other questions or need some more explanation, please reach out to me on any of those social media formats or comments below. Just your thoughts. Oh boy. Wow. Brilliant.